In this section, we're going to configure our postfix systems in smarthost configuration. Now, you can apply this configuration to your mail environment, which may include a back-end Exchange, Lotus Notes, or Oracle Collaboration Server in conjunction with front-end postfix systems for receiving messages, perhaps in your demilitarized or DMZ zone. Let's log in, take a look at the architecture, and we'll see what we can do to construct the smarthost environment. The idea behind a smarthost is to permit only the systems that are in the demilitarized zone to relay messages outbound to the internet. And chances are likely you already have set up DNS for the systems that are in the DMZ, and you'd like those systems to be the lone communicators with the outside world. I mentioned systems because ideally you should have in your DMZ some sort of load balancing device which essentially masks the multitude of systems behind it so that you can have a pretty bulletproof mailing system, at least within your site. So let's take a look at the current configuration. Now, our host name can be revealed using the hostname-f option, which reveals it as linuxcbt suzyserv1.linuxcbt.internal. This is the primary system that we've been operating on. But we also have a system called linuxcbt work1.linuxcbt.internal. This particular system is currently our primary DNS server. It's running SUSY Professional, but besides the operating system that it's running, of course it's Linux, it is our primary DNS server, so any DNS changes that we make should be done on this particular system. They're both running postfix, as you know. So what if we wanted to redirect messages in smarthost fashion? We then need to determine which system is going to play the role of the actual smarthost, the system who has proper DNS resolution for sending messages outbound, and so on. So what we'll do is we'll pretend that our enterprise system is the internal corporate system which houses all of the mailboxes and receives messages only from the DMZ system, which we'll consider to be the smarthost. The relationship is as follows. Server, which is the SUSY Enterprise server, to SUSY Pro, which is the DMZ smarthost. And then the smarthost is able to resolve systems on the internet. Now, we're doing this simply because currently the SUSY Pro box is the primary DNS server, so the assumption is the server that functions as the primary DNS server is the system that will permit proper name resolution out to the internet. So how do we alter our configuration so that this becomes the reality? The default configuration in postfix is to actually attempt to deliver messages directly, and that's indicated by the relay host directive, that is, being not defined or undefined. And because it's undefined, postfix will always attempt to deliver the message directly to the receiving SMTP host. The receiving or recipient's SMTP host is determined by performing usually a DNS MX lookup. And if not an MX lookup, postfix will consult its transport table, which we recently looked at. So again, postfix in our local system will attempt, let's pick a domain such as Google, for example. We'll dig google.com/mx. If we were to source a message from this enterprise box or to relay a message through this enterprise box to a recipient at Google or Gmail or whatever the domain is, our local SUSY Enterprise postfix instance will perform an MX lookup for the domain Google, and these various MX records will be returned. Some are at equal weightings, some are at higher weightings. Of course, the lower weightings, as you know, will likely receive the messages according to the SMTP and MX specifications. And postfix will attempt to deliver those messages directly. However, that may not be desirable within your environment. You may want to direct traffic through your demilitarized zone and permit only certain systems to actually touch the internet. And the way you do that is you define the smarthost. So let's go about doing that. Now again, the smarthost definition works only for non-local messages. A local message will always be delivered unless you turn it off and turn the system into a null client, which we look at next. We'll always deliver messages locally to the local recipient, which is generally matched with the my-destination variable. Let's authenticate. We'll navigate into etc postfix, the home directory for our configuration files. Now when we execute the postconf command and we grep the my-destination parameter, it's currently set to be my host name, followed by localhost, followed by my domain. And as you now know, since we've reiterated it so many times, postfix will attempt to deliver messages to any user at my host name, which expands to the fully qualified domain name. It'll also attempt to deliver messages to any user at localhost, as well as any user at my domain, which is just the domain part of the fully qualified domain name. Any other domain portion, so user at domain, any other domain portion is considered to be non-local and needs to be resolved by either communicating directly or indirectly in smarthost configuration. And as we've shown you with the transport table, you can also dictate the route that messages will take by specifying those routes using the transport table. Super. So now that you understand that, let's actually set up our directives. We'll modify the main.cf. This is where most things get done, of course. And we'll search for the relay host directive. The relay host directive, again, allows us to turn this baby into a smart host. We can specify the relay hosts in a variety of ways, or in a plethora of ways. Let's explain them. This example here will actually perform internal MX resolution. So if we use relay or specify relay host equals my domain, then postfix will attempt to resolve the MX or mail exchanger for my domain using typical DNS queries. Again, that results in DNS lookups. If you want to avoid DNS lookups, avoid using the my domain value. Relay host equals, within brackets, pay attention to the brackets, gateway.my.domain will actually not perform a DNS MX lookup, but will actually look up gateway.my.domain and relay messages, non-local messages, through this particular host. Ditto for the next value. UUCP host is also a separate value for rerouting messages through a given host that'll handle UUCP messages. And then relay hosts, which are based on IP addresses, which again is pretty straightforward. So what we want to do is define our relay host to be the remote system, which is the Linux CBT work1 box. We're going to use brackets to avoid the MX lookup to save our postfix implementation the extra hassle. Again, as usual, it's a good idea to comment, so we'll comment here, added by Dino on a given date. Followed by relay hosts, which again is undefined by default, is equivalent to, within brackets, Linux CBT work1.linuxcbt.internal, which we'll consider to be our smart host. Let's exit this section. Now again, before we reload postfix, we'll execute a postconf, and we'll again grep relay. This time we'll be more specific and grep relay host. Notice it reads the configuration entry that tells you that you've specified it, but it isn't in effect currently. In order to place this into effect, let's execute postfix, reload, and now postfix knows about the smart host, which means when we attempt to generate a non-local message, which of course does not match the transport table. The transport table currently contains the domains .external, computer-based training internal, computer-based training external. So we need to redirect a message outbound to a real domain such as linuxcomputerbasedtraining.com, which we certainly have a user set up to receive messages for our demonstrations. Excellent. We'll use our mail user agent, mutt, to compose a new message, and we'll send this message off to root, which is an optional user on the remote system, or we could send it to Linux CBT SUSE1, either or, at linuxcomputerbasetraining.com. Now this is a real domain on the outside. It's a top-level domain that's routed on the internet, and a second-level domain that we own with a valid user. So what will happen here is our enterprise box will recognize that it's a non-local domain because it doesn't match my destination. It'll then consult the smarthost, linuxcbtwork1.linuxcbt.internal. The smarthost, if configured to permit relaying, will then attempt to relay the message onto the internet. In the subject, we'll simply specify testing smart host configuration. We'll ignore the body, it's not required. We're not going to CC anyone. Let's simply execute Y to send the message. Now when within MUT, simply use the arrow key to navigate up and down, and usually if the message bounces pretty quickly, it's returned. Let's quit. We'll then tail var log mail, which is the default log file within a SUSE environment. And as you can see, the message was actually relayed to linuxcbtwork1.linuxcbt.internal. Again, the message was destined for a user called linuxcbtSUSE1 at linuxcomputerbasetraining.com, a real second-level domain. But our system is now configured in smart host mode, which means if the domain portion, so again, user at domain, if the domain portion is not local, relay it, and of course, and if it doesn't match what the rules that are specified, the routing rules specified in the transport table, relay using the smart host, which is invoked using the relay host directive. And that's of course specified in the main.cf configuration file. Again, by examining the log files, you should always be able to tell which relay host was consulted for relaying the message. Now we can confirm whether or not the message made it to its final destination. It did indeed, within or under a full second, make it to the next hop, which is linuxcbtwork1. Let's Control-Shift-N, and we'll simply SSH over to linuxcbtwork1. We're going to do so as root at linuxcbt.internal. In fact, we're going to make this dot and make it the user root at linuxcbtwork1.linuxcbt.internal. We'll authenticate, and on this remote system, let's tail var log mail, and we'll see whether or not the message made it to its final destination. Always examine the logs and compare it to the current time. Now there may or may not be some differences depending on the synchronization methods used. If you're using NTP within your environment, which you should be, then the clock should be pretty much identical. Great. Now here's the message. 1.30 relayed the message in from root at linuxcbt.internal. This is 1.30, the SUSE Enterprise box on the left. The message was then forwarded to mail.linuxcomputerbasetraining.com, the real production system located on the 12 subnet. It took 3 seconds to route this particular message out, much shorter than our session thus far. The status is sent. The status is good. There's an ID. It was accepted for delivery. We simply need to confirm whether or not the message actually made it. So in a totally separate shell, let's SSH, and since the user is linuxcbtSUSE1, we don't need to specify the user, to mail, and again, you can check based on the relay host, mail.linuxcomputerbasetraining.com. So let's SSH into this host. We'll authenticate once the password prompt returns, and it has. We're now on the remote system, and sbin ifconfig will reveal the remote system's IP address, which is on the internet. We'll then launch MUT on the remote system. There are other messages from other tests. We'll delete the other messages, but here is the most recent message, which is towards the bottom, testing smart host configuration. The user agent that was used was MUT version 1.5.6i to send the message. Pressing H will reveal the entire header of the message, which shows that the message's return path is root@linuxcbt.internal, which the system on the internet cannot respond to because it's not resolvable on the internet. Unless, of course, we set up a transport map or rig the DNS so that it knows how to find its way back in the event of a response. And here's the path the message took. linuxcbt SUSE-serve1 was a server, or the server that originated the message. It was then forwarded through linuxcbt work1, which then aliased out as our internet address, which then made it onto the destination system into the proper mailbox. So we're currently set up as a smart host. We really don't need to test many other messages because you should understand the logic. Our SUSE enterprise system now has a directive we'll execute again to show you. Postconf grep relay hosts. So our internal corporate box, which is what we're pretending this system to be, has a relay host that's set to linuxcbt work1, which is located in shell number 2. Shell number 2 isn't considered a local destination match for linuxcomputerbasedtraining.com, so it relays it. Now, if you're wondering why does it relay it by default, because the way postfix works is that it'll relay messages for clients on its subnet by default. So unless you go in and make changes to restrict relaying, postfix is liberal enough to allow local members of its subnet to relay messages. Shell number 2, which is work1, sent the message onto the internet to one of our production systems, and the message made it to its final destination. So for subsequent messages, if they're considered to be non-local on our internal enterprise box, they'll be forwarded out to our smart host, which we're pretending to be in the DMZ, which will then forward it on to its destination. And vice versa. Messages from internet systems should be forwarded to your DMZ box, screened perhaps with some sort of spam, content filtering, and so on, and then relayed into your internal system. So you should have a tiered setup. In this model, we have a 3-tiered setup where the internal corporate system is protected, doesn't actually have internet access. It goes through an intermediary box, which is located in the demilitarized zone, which then forwards to the internet, and so on. And messages from the outside routed to our DMZ back into the corporate backbone. So that's really all there is setting up a smart host. There really isn't much to it. Again, as long as you understand that, as long as the domain portion of the receipt to address does not match the local my destination, it'll be considered non-local and then be forwarded to smart host. It's treated the same way on the smart host if it's running postfix or any other MTA, which will then forward it on.